Okay, this is 8th grade chapter 4.1 lesson. The objective, students will review input and output patterns. The standard covered is 8F1 and 8F2. The page numbers out of the hardcover book are pages 147 through 153, and out of the practice journal, pages 77 through 80. Today, you're going to go ahead and need to have your practice journal out to work through the stuff that we're going to be doing together. Okay, so we're going to work a little bit with some vocabulary first of all. You have to have a really good understanding of the vocabulary when working with function. It's actually a very, very easy concept, but if you don't understand the vocabulary, it seems very confusing. So first of all, a function is a relationship that pairs an input with exactly one output. So we're going to discuss what an input is versus an output. Okay, inputs are going to be your x's. Your outputs are going to be your y's. So it's working kind of with a set of coordinates, okay? The domain is a set of all possible input values, so your x's. Your range is going to be all of your possible output values or your y's. So really you're talking about x's and y's here. They have some different names. So your x's could also be referred to as your inputs. They could also be referred to as domains, okay? Your y's could be referred to as either y's, your outputs, or your range. Okay, so you have domain and range. You also have input, output, and X and Y. Okay, they all are representing the exact same thing. It depends on what you're working with as to what terminology they're using. So here, first of all, just to explain a function a little bit better, a function is going to be an equation. So here we have an equation that looks like something that we've done before in one of our first 3 chapters. We worked with some y-intercept equations. Okay, we could go through and actually substitute in x's and then graph this information. And we could list all of the possible outcomes for our x's and y's. So here they're kind of showing us what I would call a function machine. And they're inputting on the left-hand side here a -2. So our input or our x, also known as our domain, is -2. So they're going to put that -2 in the machine and it's going to go through this function. It's going to follow this function. So they're going to put -2 where x is. So y equals 3. And then -2 has been inputted into that equation. So when it shoots out on the other side or the right side, we find out that y equals -6. Okay, so that -6 is known as the output or the range. So how do I keep each of these separate? Well, first of all, it is a lot of memorization and just understanding what is what. A lot of this section is going to be with vocabulary, terminology, and understanding the difference. They're going to have you just list domains and ranges. They're going to have you list inputs and outputs just to get you comfortable with that vocabulary. Okay, so how do I keep them separate? Well, my domain, first of all. One way that maybe you can help keep it straight is your domain. When I think of a domain, it would be like where you originate, kind of like your house, your domain. Okay, it also has, in the end, domain has the word in it. So that's your input. It's also where you start off, like in the morning, you start off at your house. Okay, that is your X. When you think of coordinate sets, your X's are what you start with. You guys go over to your X's and then up or down to your Y's. So domain is the same as your input, which is also the same as your X's. Okay, those mean the same thing. Okay, sometimes they're going to ask for domain. Sometimes they're going to use the wording input. We are used to using X's. Okay. The range then is what you would spread out to. So when I think of a range, I think of either like a golf range, what you would hit, how far you could hit, or how far away you could hit from your original spot. Or maybe I think of like a ranch, like letting your the animals kind of go out on the range. Okay, but the eyes originate from the same ranch. So a range is what you spread out to. So that's your output, also known as your Y. So when you think of coordinate sets, you have X's and Y's. Okay, another word for your X's would be your inputs. Okay, so then your Y's would be your outputs. Okay, another word is going to be domain and range. So you originate in your domain. So those are your X's. And you go out to your range, which would also be your Y's. So just understanding that different vocabulary is very, very important for this section. Okay. One other thing that I want to make sure I go over is that you understand what a function equation is. So a equation is going to be in function form when it is solved for y, or when y is isolated. So for example, this first equation right here, x plus y equals 1, is not in function form because the y is not isolated by itself. It still has this plus x there. Could we get it into function form? Yes, we could. We could practice like we did in the first 3 chapters by getting rid of that plus x by subtracting x, okay? This is an example of function form. When you have that y isolated and you're solving y equals blank. So we're used to calling that y-intercept equation format, okay? We've worked with this before. This isn't new. It's just working some different vocabulary and understanding input and outputs, domains and ranges, okay? So here, you're gonna need your practice journal. Open that up to page 77. We're gonna work through this together. So here we have a table that shows the number of adult and child tickets that are sold for a school concert. So we've got the input. They have went ahead and labeled that off. They're not always going to do that. So remember that your input are anytime they give you your x's, okay? That's also your domain, okay? Your output are your y's, or also known as your range, if they use that word instead. So here it says the variables x and y are related by the linear equation 4x plus 2y equals 16. So in other words, what they're saying here is in this equation, we've got 4 x's, and our x's represented adult tickets, plus 2 y's, and that's going to equal 16. So in other words, what they're saying is we are going to be able to buy some adult tickets and some child tickets, and in the end, we can only spend $16. So this table is something that we worked with actually earlier in the year, where we went through and gave all of the possibilities, okay? So for example, we have our 4 x's means our adult tickets cost $4 each, okay? Our child tickets are those $2 each. So in other words, we could buy 8 child tickets, which would be exactly $16, which means then we couldn't buy any adult tickets. That's where this 0, 8 comes into play, just so you understand what the table means. Okay, here we've got where we could buy 1 adult ticket, so that would be $4, which then leaves us with what? 16 minus 4 gives us $12. So that means we could buy then 6 child tickets. 6 times 2 gives us the $12. Okay, so you're understanding where they're coming up with these numbers. Okay, so the question A says, write the equation in function form. So remember, function form is when we get it into that y equals format. So we have 4x plus 2y equals 16. Now you're doing this in your book, so you're filling it out as I'm filling it out. So we want to work to get this y all by itself. Okay, so I'm going to first box around this because I know that I have to leave that there and get rid of anything else. So how can we get rid of that 4x? Well, right now it's positive 4x, so we're going to subtract 4x. Okay, remember, whatever you do to one side of your equal sign, you have to do to the other. Now, you guys are used to having these equations with the x in the front part. So now this is what I have. I'm just going to rearrange. I have 2y equals, remember when if I rearrange that negative has to stay with the 4. And then that's a positive 16. Okay, now I still have to get y all by itself. So I need to get rid of that 2. So I'm going to divide by 2. And then each of these is divided by 2. So our final answer for A is y equals negative 4 divided by 2 is negative 2x plus 16 divided by 2 is 8. Here is the equation that we can use to solve all of our x's and y's, okay? Okay, so that's your letter A. I'm just going to write that out off to the side in case I need it later. Okay, so now we're going to go ahead and look at our B. So the letter B says, and I'm going to need this because I need the table, the domain of a function is the set of all of the input values. Find the domain of the function. So here we are checking basic vocabulary. So domain, remember when we discussed domain, it's got the input. Also, where you originate, where you start in your set of coordinates, those are your x's. So these are all of your domains. So when it asks for you to either give the input or the domain, you're just going to list those numbers. So the domain is 0, 1, 2, 3, and 4. Okay, letter B, this next question says, why is 5 not in the domain of the function? So in other words, why do we not have 5 out here? Okay, remember, we only had a certain amount of money to spend. Could we buy 5 adult tickets if each adult ticket was $4? No. Okay, so why is that not in the domain of the function? Okay, we can't buy 5 adult tickets and only spend $16. Okay, why is X equals a half not in the domain of the function? So why can't we put something like this in here, a half? Okay, remember that 0 is representing 0 adult tickets. That 1 is representing 1 adult ticket. Why can't we buy a half? Because we can't buy a half of an adult ticket. Okay, so that's just understanding. Sometimes we're going to graph these things, and eventually in one of our future lessons, we're going to learn that sometimes we draw a line through our stuff and sometimes we leave it as just dots. And we'll understand that a little bit more as we continue through this chapter. Okay, let's go ahead and look at letter C. So letter C says the range of a function is the set of all of the output values. Find the range of the function. So remember our domain was our input or our x's, and our range is our output values. So this is all labeled. Our output values, also known as our range, would be 8, 6, 4, 2, and 0. So it's all of these right here. Okay, once again, working vocabulary, making sure you're getting comfortable with input, output, as well as domain and range. And letter D. Letter D says functions can be described in many ways. They can be described as an equation, like we did here. Here's an equation of our function. They can be an input-output table, so something like this. They could be written in words, so using that word problem format. They could be described as a graph, so here's an example of a graph, or a set of ordered pairs. It says use the graph to write the function as a set of ordered pairs. So we're going to go ahead and do our ordered pairs. So our coordinates for this, remember it's either over then up or down. So our x, we went over to 0. And we went up to +8. So 0, +8. Okay, so now we're going to go ahead and do this next dot. So we went over to 1, up to 6. Our third dot, we went over to 2, up to 4. Okay, so obviously that's something that you have done before. You've worked with coordinates since probably 4th or 5th grade. So you're going to go ahead and finish out working through that coordinate set there and writing out the coordinates of those last 2 points. Okay, so that's basically the big information out of that part, is that working and understanding domain and range. So go ahead and turn your page to, or your journal book to page 78. Okay, we're going to go ahead and work through page 78. It says complete the table, then find the domain and the range of each function. So domain, remember, that's also known as our input or our x. Okay, our range is our output. And remember, input always has the word in domain. Okay, your range is what you go out to, or your y's. Okay, so when we look at this, well, I could do my domains right away before I even solve anything, because they're already listed right here. This is my domain, also known as my input, and my x. Okay, so my domain is 0, 1, 2, 3, and 4. Okay, so now to figure out my range, I'm going to have to substitute in and solve for each of my ranges. So if I substitute in 0 here, 1/2 times 0 is 0. Minus 6 gives me a negative 6. So that's one of my range numbers. Okay, so now we'll go ahead and substitute in a 1 there. 1/2 times 1 minus 6. So half of 1 is half. Minus 6 is going to give me a negative 5.5. And if you need to use a calculator with this, you can do that. Okay. So now we'll go ahead and substitute in, instead of a 1, we're going to do a 2 here. Okay. Half times 2, or half of 2, is going to be a 1. 1 minus 6 gives me negative 5. Okay, now you can probably see the pattern that's happening. If you look and notice, remember when you did your fair game review, there's always a pattern in a function table. So like here, we kept increasing by 1. Here, it looks like we're increasing by a half. And I know some of you might say, that's not increasing, it's decreasing. Remember, you're working negative numbers, so it really is increasing. So we're going up by a half. So if I continue the pattern, this would be negative 4.5. And then it would be negative 4. Or I could continue to substitute in and solve the equation. But some of you are going to start to see that pattern. Okay, so there's my domains and my ranges for my first table. Okay, so that was table B. I apologize that I had letter B written out there. Okay, so A, you're going to actually do independently. I'm trying to do the ones that are a little more complex. Okay, so letter D, we have a set of coordinates here, or a graph, and they want us to write the domain and ranges. So remember, when you do domain and range, those are your X's and Y's, your XY coordinate set. Okay, so for example, this point would be over to 2 up to 0. That would be 2, 0. So this is my X, this is my Y. So it's actually going to be 2 with a 0 on the bottom because of the way they set up this table, okay? My next dot over is over to 3 and then up to 1. Okay, the next one is over to 4, up to 2. And once you get the idea of how it's set up, you don't have to write them out left to right. You can do your top to bottom. So then this point here is over to 6, up to 4. And my last point is over to 9, up to 7. Okay, now granted, you'll notice here that it looks like there is a function that's going up by 1, and then all of a sudden it's 2, and then it's a 3. But you have to realize all they did was they skipped some of those points and they didn't do every single line on the graph. Okay, so realize you may not always see that pattern, but there really is a pattern if it creates a straight line. Okay, so my domains are my X's, also known as my inputs. So my domains are 2, 3, 4, 6, and 9. And my ranges are also known as my outputs or my Y's. That would be 0, 1, 2, 4, and 7. Okay, so I want you to go ahead and turn to page 80. We're going to go through number 5 on page 80, which is part of your homework. So we're going to go ahead and do this one together. Okay, so on page 80, number 5, it says a factory makes frozen pies and that produces 300 pies per minute. So it can make 300 pies in a minute. Write an equation in function form that represents the number of pies made each hour. So for every hour, how many pies could they make? So if they could do 300 pies per minute, well, we've actually got 60 minutes in an hour. So we're going to have to take 300 pies times 60 to figure out how many it could do per hour. So if I do 300 times 60 minutes, that is going to give me what, 1,800? No, 18,000. I forgot I would need 3 zeros. So we can do 18,000 pies per minute. And they wanted hour, or not per minute, per hour. Okay, they wanted us to go ahead and represent hour with an X. So our equation is going to be Y, our number of pies, equals 18,000 X. And you could leave that X without it being in a parenthesis also. That's the equation that we're going to use. So now it says create an input-output table for the equation in part A. Use the inputs 1, 2, 4, 8, and 10. So we're going to go ahead and draw a table really quick. And they want us to use inputs of, so our input, also known as our X versus Y, also known as our domains versus our ranges. Okay, so getting comfortable with that vocabulary. So it says use the inputs 1, 2, 4, 8, and 10. So we're going to go ahead and substitute those in where X is up here. So if I do 1, well, obviously that's going to be 18,000 pies in 1 hour. Okay, in 2 hours, well, we would substitute in a 2 where X is 18,000 times 2 is going to give me 36,000. Okay, so now we'll go ahead and substitute in a 4 where X is. So 18,000 times 4 gives me 72,000. And now we'll go ahead and substitute in an 8 up here. So now we're putting an 8 there. 18,000 times 8 is going to give me 144,000 pies in 8 hours. And in 10 hours, it's going to give us 100. If I substitute in now a 10 there, it's going to give us 180,000 pies. So we could make 180,000 pies in 10 hours. Wow, that's a lot of pie. Okay, it says find the domain and the range of the function represented in the table. So they're having you check your vocabulary. So our domain, I'm just going to put a D, also known as our inputs or our X's. Our domain was 1, 2, 4, 8, and 10. Our range then, also known as our output or our Y's, was 18,000, 36,000, 72,000, 144,000, and 180,000. Now, those are not the only ones. Those are just the ones that we represented in our table. Could we continue this out? Yeah, we could check to see how many pies we could do in 11 hours or in 15 hours, but these are the only ones that they asked for, so those are our only domains and ranges, okay? So that's it for this lesson, or at least this part of the lesson. Tomorrow we're gonna go through and do some word problems working with domain and range. So for your homework, I want you to go ahead and finish out pages 78 and then also page 80 out of your practice journal. Good luck with this lesson. Just remember your domains are the same as your X's, also known as your inputs. Your ranges are also known as your Y's or your outputs.